Let's understand how Kubernetes queries or probes the status of individual containers within a pod. For this, remember that pods are going to run on nodes or minions. Each node is going to have three components running on it. The first of these will be a kubelet, the second will be a kube proxy, and the third will be the container engine, a runtime such as Docker. The probes which query container status are dispatched by the kubelet. In effect, probes are diagnostics which are going to be performed periodically by kubelets on all of the containers within a pod. Based on the status of the individual containers within a pod, the overall status or phase of the pod is determined. For instance, if all of the containers in the pod have terminated successfully, the pod status phase will be set to succeeded. If at least one container in the pod has terminated in failure, then the status of the pod will be set to failed. If all of the containers have been created, but at least one container is still running or is in the process of starting or restarting, then the status of the pod as a whole will be set to running. We will not go into the nitty-gritty of how the kubelet actually invokes handlers to probe the status of the containers. There are actually three different types of handlers. What we should know is that all of these probes have one of three possible results: success, failure, and unknown. In addition to these types of probes, a kubelet can optionally perform and react additional kinds of probes on running containers. These are liveness probes and readiness probes. If the liveness probe fails, then the kubelet concludes that the container is no longer alive. The kubelet will then kill the container, and depending on the restart policy of the pod, it may try to bring the container up again. If a container does not provide a liveness probe, then the default state of this probe is set to success. Readiness probes, these indicate whether containers are ready to service requests. If the readiness probe fails, then the endpoints controller will remove the pod's IP address from the endpoints of all services which match the pod. More on this when we talk about services. The default state of readiness, by the way, is set to failure. Liveness and readiness probes are only admissible under certain specific circumstances. Let's say, for instance, that you would like your container to be killed or restarted if a probe fails. Then you can specify a liveness probe as well as a restart policy of always or on failure. If you would like to start sending traffic to a pod only when a probe succeeds, then you should specify a readiness probe. In this case, that readiness probe might be the same as the liveness probe, but the existence of that readiness probe in the spec means that the pod will start without receiving any traffic. It will only start receiving traffic after the probe succeeds. If you want your container to be able to take itself down for maintenance, you can specify a readiness probe which checks on an endpoint specific to that readiness probe, and this could be different from the liveness probe. Lastly, if you just want to be able to drain requests from a pod when it is being deleted, you do not require any probe at all. The pod will automatically put itself into an unready state and carry out connection draining.